In this video, we're going to cover naming of alkynes. Before we get into examples of naming alkynes, here are a couple substituents that it's helpful to know. In this first one, you have 2 carbons, which is an ethene. So if this is attached to a larger parent chain, this would be an ethenyl group. In this case, you have a 3-carbon chain. So if it's a substituent, you would start from the point of attachment to the parent chain, and you have your alkene at position 1, 2. So that's where the 2-propene comes from, and the YL is because it's a substituent, so this is a 2-propenyl group. Alkynes have the suffix YNE, so when we go from an alkene to an alkyne, instead of a propenyl, we have a propinyl. Again, numbering from the point of attachment to the parent chain, 1, 2 is where our triple bond, so that's why there is a 2 there in front of the propyne. All of these groups also have common names, which are helpful for you to know. They're listed in parentheses here. The ethenyl can also be referred to as the vinyl group. The 2-propenyl can also be referred to as the allyl group. And the 2-propinyl can also be referred to as a propargyl group. You can see some examples here of how we might use those common names. In this first example, technically the IUPAC name would list this as our parent chain. So it would be a cyclohexylethene. However, commonly it's referred to as vinyl cyclohexane. In our second example, the parent chain would be here. Numbering from the left, that would put the bromine on position 3. So its IUPAC name is 3-bromo-prop-1-ene. However, this is commonly referred to as allyl bromide. In this last example on the right, here's the parent chain. We number to give the lowest possible number. So you end up with a 3-chloro-prop-1-ine. Commonly it is referred to as propargyl chloride. While I won't test you on these common names, they are useful to know. In this first example, here we have our alkyne. Our alkyne is a suffix-changing functional group, and it's going to change the suffix to YNE, or ine. The parent chain must contain that suffix-changing functional group, so our parent chain is going to be here. And we need to number that parent chain to give the alkyne the lowest possible number. If we number from the left, we won't have the alkyne until 1, 2, 3, 4, 5. So we want to number from the right to put the alkyne at 1, 2, 3. There is a methyl group here at position 6. So if we put this all together, we have a 6-methyl, oct, 3, ine. The 3 refers to the first carbon of the alkyne. There are 8 carbons in the chain, and that's where we get the oct from. In this second example here, we have 2 alkynes. Our parent chain must include both of them. Here's our parent chain here. And we want to number to give the first alkyne the lowest possible number. If we number from the left, 1, 2, 3, we won't see an alkyne until 3, so we want to start from the right because that will put an alkyne at 1 here. There's a methyl group right here. So when we put this all together, we will have a 6-methyl, hepta, 1,4 diine. Hepta refers to the 7-carbon parent chain. We needed to put the A in there because we had 2, and so we need to add it because of that di. And our alkynes start at 1 and 4. So that's where we get the 1,4 diine. In this example, we have both an alkene and an alkyne. Our parent chain must include both. So our parent chain is going to go this way and include both the alkene and the alkyne. We don't have any particular preference between the two, but we do want a number to give lowest possible numbers. If we number from the right, 1, 2, we won't get anything until 2. So we want a number from the left to put our alkyne at position 1. There's a methyl group here at position 4. So when we put this all together, we will have a 4-methyl. Non is for the 9-carbon parent chain. 7-ene, and the ene refers to our alkene here. 1-ine, and the ine refers to the alkyne here. We have to put the ene before the yne because of alphabetical order. E comes before Y alphabetically. The last thing we need to do is add the cis-trans designation for the alkene here. If you draw on the hydrogens here, you can see that they are on opposite sides. So that is going to give us trans right in front here. In our last example here, again, we need to include both the alkene and the alkyne in the parent chain. So here's our parent chain. When numbering our parent chain, if we start from the left, we get a 1. If we start from the right, we get a 1. In this case, we have a tie, so we have to use alphabetical order to decide which one wins. Alkene comes before alkyne alphabetically, so we're going to number from the right. There's our methyl group at position 5. So if we put this all together, we have a 5-methyl, oct, 1-ene to indicate where our alkene is, 7-yne to indicate where our alkyne is. Just to summarize what we did there, the first thing we want to do is to give the alkene or alkyne the lowest possible number. When we have a tie between both, in that case, the double bond is given priority, and that's because of alphabetical order, ene coming alphabetically before yne. This concludes nomenclature of alkenes and alkynes. In the next video, we're going to look at how to name benzene and benzene derivatives.